Hello, my name is Anthony Huvetta, and today I'm presenting my project, Inclusive Voice Control Interface in Virtual Reality. My project explores how we can use voice commands to navigate virtual environments hands-free, making VR more accessible for individuals with limited mobility, especially with their hands. One of the biggest challenges with traditional VR is the reliance on handheld controllers or gesture-based input. So most VR interactions rely on controllers or gestures, and accessibility is often overlooked in commercial VR applications for people that really just that cannot use their hands. For example, people that have quadriplegia and they can only move their heads and mouths. So my goal is to build a system that allows speech-driven, hands-free navigation. My system runs on the Oculus Quest 3 headset and was built using Unity for the VR development software. I also implemented the Wit.ai, it's supposed to be I. It's a voice command processing. It uses AI to try to process a user's commands. And so the commands that I ended up using, for example, were forward 5 steps, or back. If you just said back, it would go back once. If you said back 5 steps, it would go back 5, and the same with forward. I also used head tracking for turning, and so this is fully hands-free navigation and interaction. For my methodology for my project, I used 4 participants that varied in age from 7 to 62. Now, this wasn't an unbiased pool this was my own family, so this is a mock, a pilot study. But each participant navigated a VR maze using only voice and head turns. I recorded the variables like task completion time, errors, missed and unrecognized commands, and then after each participant participated in the maze, they did a user feedback survey. Just made a real simple maze, nothing too fancy. So when the user turns their head and it reaches a certain point, it will turn the whole camera. It does it for both sides, about a 45-degree angle, and forward 5 steps. Forward 5 steps. Okay, so it wasn't the most intuitive. It's picking up me talking, but forward 10. Forward 10. Back 10. And so yeah, this is how they'll navigate.
Forward 3. Forward 2. Okay. Forward 6 steps. Forward 2 steps.
Forward 5 spaces. Forward 5 spaces.
Forward 5. Forward 2.
So this table shows the results for each participant. Interestingly enough, the older participant who had no prior experience with VR or really any 2D game interfaces, they scored, though they had a higher success rate and took less time to complete the maze compared to others who actually, like my children, who actually had experience with VR. So the takeaway is that clear speech was more important than age or prior VR experience. The short survey, they rated the system high in terms of accessibility and overall satisfaction. However, the feedback also pointed out some challenges, like one participant experienced dizziness, and then 3 out of the 4 participants had a problem with the recognition and lag. So this helps identify areas of improvement, like speeding up system response and adding confirmation feedback, possibly. So, yes, if we also possibly implemented local offline voice processing and had models be trained on a more diverse pool of participants with different speech patterns. So, yes, voice navigation does seem to be a possibility when implemented correctly. And this is just another opportunity to include all diverse people in the world. Thank you.